Check. Oh, perfect. All right. Welcome, everybody. Appreciate you guys being here so late. I know there's other fun stuff happening after this, so we'll try to keep this brief and to the point. My name is Abhishek Singh. I am the general manager for the AWS X-Ray service. Today we'll be talking about or taking a deep dive into X-Ray and how you can use X-Ray to monitor modern web applications. With me, I have Kit and Mina from ConnectWise. They've been our customers, or X-Ray customers, since we launched at re:Invent about 2 years ago. So they'll be sharing their journey on how they started using X-Ray and what they're using X-Ray for today and how X-Ray is helping them benefit and reduce costs. And with that, let's kind of quickly talk into or look at what we expect from the session today. So we'll talk a little bit about what modern applications are. We'll talk about the challenges of monitoring modern applications, and then we'll talk about how X-Ray benefits customers running modern applications and how you can very easily get to diagnose or troubleshoot the problems you're running into. Kit and Mina will talk about their customer story, and then I'll do a demo to show you guys what X-Ray is all about. And for those who are here at the end of the session, as part of the demo, I'll be introducing a new feature that we're launching, as well as preview of some features that we have to come. So that's just a special treat for you guys for coming in here and being here so late. And then we'll do Q&A. So we'll try and keep about 10 or 15 minutes towards the end for Q&A. I do want to take a quick poll here. How many folks are using X-Ray today? So I see it's a good chunk of the room. How many people don't know what X-Ray is and would like me to give you a brief history and kind of go in from there? So a few folks. All right, perfect. So I'll try and manage both of those competing constraints and try to address both of those. So let's start with what are modern applications. So as all of you may be aware by now, modern applications are essentially service-oriented applications that are built using containers or serverless architectures. And the problem essentially that happens, or the benefit of those architectures, I should say, is essentially that you get to decompose your large applications, get to scale them vertically, or horizontally, I should say, instead of vertically, and take the benefit of cloud, right? So you essentially get to individually scale things as they need to be scaled. You don't waste any resources in scaling large monoliths because your payments API requires more processing power, for example. And that's part of the second piece is that since each component is independent and autonomous, your teams get to run much faster and you get more agile as a business. One of the challenges that comes in with modern applications is how do you understand the impact of issues and errors? And that's where X-Ray is going to come in, and that's where X-Ray helps. So let's talk about traditional debugging and why traditional debugging does not scale for modern applications. So as you can see, I have an application architecture here that has a few different services. It has a database. In most applications today, you've got essentially logs that are disparate, disconnected, and when you have issues in systems, you may start with, hey, I have an issue in my payment service, and then as you start digging into the logs, you realize that it was because of the database, and then you start digging into your database logs, and then you realize, oh, it was really because there was a client-side issue where the client sent me a different input that I was not expecting. And so you're chasing essentially logs in disparate systems that are not interconnected. And the feedback that we've heard from customers who are doing this today is essentially that they spend anywhere from a few hours to a few days diagnosing these issues and root causing them. And what we will show you, both as part of Kit and Mina's journey, as well as the demo, is that how you can use X-Ray to solve this problem in about 5 minutes or so. So something that takes hours today, if you're not using X-Ray or a tracing tool, you can essentially reduce that to minutes with these tools. Let's talk about how tracing connects the dots for modern applications. So essentially, one of the benefits of tracing is that because we're looking at the application from a logical standpoint, we can give you a real-time view of how your applications are interconnected. How are they talking to each other? Where are errors and exceptions happening? How do those things flow in the system? So you essentially get a good architectural overview of your application. We also give you insights into individual operations. So because traces are essentially detailed, in some sense, logs of individual requests or individual operations that your users are doing, there is no aggregation there. So you can go look at exactly what happened for a particular user or for a particular API call. You can also start isolating these issues very quickly, because looking at the service map, you get a color-coded view of where you're having issues. So for example, if you're using DynamoDB and you have provision IOPS, which no longer should be a problem after today, because I just heard that they launched dynamic capacity, so that's really great news. But if you were using provision IOPS and you are looking at throttling going on at DynamoDB, with the X-ray service map, you can look at that at a glance and know exactly what's going on and what you need to do. And then finally, X-ray lets you do root cause analysis as to what's going on. So given the data that's coming in, we can look at that data and tell you exactly where the problem is, or at least point you in the right direction so that you're not spending a ton of time looking at multiple places. Let's quickly talk about what does tracing for your modern applications look like. So here, again, I have the same architecture. I've got some API gateway, some EC2 instances in there. I've got a Kubernetes cluster that's running my containers. I might be using some Lambda containers, or Lambda functions, I should say. And I'm using Dynamo here as an example. So everything happens from a customer standpoint or the user standpoint. And it starts essentially with a trace. So a trace encapsulates, as I mentioned earlier, the end-to-end transaction that was originated at the user. And you get to look at it with a holistic sort of viewpoint. Then we break that down into segments. Segments are essentially chunks that come from individual services. So this is where we take today's sort of architecture of sending logs, if you will, in disparate, disconnected containers, and we tie it all together for you so that you don't have to do all of that hard work of propagating IDs and figuring out, if it was request X on my payment service, it's request Y on my API, like how is that connected? We do that for you. And then the third piece that we have is the notion of subsegments. So in X-ray, subsegments represent either remote calls that your application's making, so it's within a service but additional level of detail, or any local code that you can instrument that you want to time. So for example, you might be running, let's say, an ML model, and that model ends up taking a long time to run, and you want to know if that model is your root cause or if that's causing slow experiences for your customers. You can wrap that in a subsegment and then start seeing that timing information in X-ray traces. So that's sort of the three, I would say, fundamental pieces that compose a X-ray trace. Now, so I mentioned all of these issues. I mentioned, modern applications are really valuable because you get to move essentially faster. But because you now have a ton of different pieces that you have to keep track of, there is a challenge there. And what X-ray essentially, the reason we built X-ray, and this is a question I get a lot of times, folks come in and they say, hey, we're using this APM tool or we're using that tool. Is X-ray going to provide me those capabilities? And the answer I give to most people is, we have great partners in Datadog, New Relic, AppDynamics, and Datadog just launched serverless monitoring, if you will, with X-ray traces as the data for that. We're really looking at X-ray as a data platform that helps developers answer these three critical questions, which is, how is my application doing? What's going on in my application? Why is my application performing the way it is? And then finally, who is impacted by these issues? So for X-ray, your end user is the king. Everything we do is about your end user and giving you capabilities that lets you essentially provide a delightful experience for your end users. The other thing, or other reason why we built Xray is that we are developers ourselves. We actually use Xray to monitor Xray. And that's a whole other talk that we'll do at some other point. But it's really been super valuable for us to learn from using Xray to really dive into the Xray service and then understand these things and then build additional tools. And the focus really has been about how do we let you very quickly get to answer these questions in a few minutes and not as much about monitoring, if you will. So hopefully that will clarify sort of our story around monitoring versus what Xray does. So let's quickly do an overview of how the Xray service works. So since some of the folks in the room have not used Xray or are not aware of Xray, kind of want to do a quick brief overview. So the way the Xray service works is essentially you integrate an SDK into your application. For different languages, we use the language-specific semantics. So if you have a Java application, you pull in some dependencies into your build file or from Maven. And essentially, we auto-instrument from that point forward. If you're in Node, you import a package, and then you essentially write a few lines of code that initializes us or puts us in the middleware. If you're in Python, you again import a package and run patch all as a command, and that does most of the instrumentation for you. So that's the first part of it, is getting your application instrumented. The second part of Xray, or how Xray works, is that we have an on-instance daemon or agent that collects the data that your SDK or our SDK is emitting from your application, and then it ships this data over to the Xray backend. The Xray backend then records these traces, right? So different segments as they're coming from different services, you can think of them as disparate log items. Because Xray uses a trace ID to stitch all of this together, we collect all of this data, these disparate log segments, and then put them together into a singular form called a trace. Once we have that trace, we then create an aggregate view of that trace, which is our service map. And then finally, we provide a set of analytics capabilities that let you deep dive into the data and answer those 3 questions that I put up there. So as I mentioned, Xray is built for modern applications, enables you to quickly analyze and debug issues. It gives you an end-to-end view of individual services as well as the overall transaction. It lets you identify customer impact. And by far, that's the most important thing that we focus on, is how do we enable you to quickly get to customer impact, right? So if you have some customer that's beating down the door and saying, hey, I'm having a bad experience, we want to make sure that you're able to go to that customer and answer that question in about 5 minutes. What was going on, why did it happen, and who else is impacted? And finally, the thing that a lot of people don't realize is Xray is actually cloud agnostic. You can run it on your data centers, colo. You can run it on your developer desktop and send data. You can use it on other clouds. We really don't care where you run the Xray SDKs or the agent, as long as you can have a connection to the Xray backend and you have the appropriate credentials. Finally, let's talk about support for languages. So as I mentioned, you got to pull in an SDK to start your instrumentation. Today, Xray supports .NET and .NET Core. We have a Go SDK. We have a Java SDK, a Python SDK, Ruby SDK, and Node.js. We are looking at other languages. All of these SDKs are open sourced. So if you're interested, you can go look at the source on GitHub. You can even contribute. We have a fairly active community of users who are contributing. Additionally, our daemon code as well is open sourced and available on GitHub. Let's quickly talk about the value proposition of Xray for serverless. So when we talk about serverless services, one of the benefits of using serverless services is that you don't have to manage anything. You are just focused on your code, or you're focused on your application logic or business logic, and then the service itself does everything. One of the downsides of that architecture, and I'm not going to talk about the upsides because everybody mostly gets that. We talk about that in various different presentations. But one of the downsides that we heard from customers was, I no longer have the ability to customize my logs or get performance data from these services because I can't get on the box, right? So we all kind of get their servers behind serverless argument. And so one of the reasons we built X-Ray was really to get you that performance data, to get you visibility into these services so that you don't have that blind spot anymore. And we want to fix that with X-Ray. Specific to Lambda, you can use X-Ray to identify Lambda retries, Lambda timeouts, cold starts. You can also look at API gateway and figure out custom auths that you have written, and really get a sense of where in your request time's being spent. And sort of, one of the reasons we built X-Ray was really to put a spotlight on ourselves and give our customers the ability to come to us and say, hey, API gateway is taking too long, or Lambda is taking too long. This is really, as much as a visibility tool for you guys, it's a visibility tool for us to really enable us to make our services better, because vocal customers are the best customers, and they enable us to iterate very quickly. In terms of turning X-Ray on for API gateway, it's pretty easy. It's a checkbox. So if you're running an API, you can go check that box, and it will just work. Similarly for Lambda, it's another checkbox. However, in Lambda, because you're running your own code, you do have to pull in the SDK for that particular language so that you can instrument the calls that are being made from the Lambda function. Let's talk about containers for a second. So from a containers perspective, again, because X-Ray is all about the details and collecting fine-grained details about each individual transaction, you can actually use the X-Ray data to figure out which container is causing issues. Right? So back in the day when we were running on VMs, you would sometimes get bad VMs, might have a bad hard drive, or you were pumping too many logs and the hard drive got full and that VM was causing an issue. Same thing happens in the container world. And you want to know if it's just a single container or if it's your whole fleet of containers, and X-Ray lets you do that. Similarly, you can use X-Ray to look at AZs and really get an understanding of, are different AZs performing differently? Do I have any differences in these systems? And finally, X-Ray supports all of our container-based services. So if you're running on ECS, if you're running on Fargate, the Elastic Kubernetes service, EKS, or if you're using Fargate, all of those services are supported. In terms of enabling X-Ray for ECS or Fargate, it's essentially adding in the X-Ray sidecar to your task definition. I have an example here, but I also have a link to the GitHub repo where you can get the entire code. So in the interest of time, I won't actually dive into that. But hopefully, folks who are interested in this, please take a screen grab so you can cover that or go look at that later. In terms of enabling X-Ray in EKS or Kubernetes, it's really about running X-Ray pods as a daemon set. Again, we have a fairly detailed blog post as well as code sample in the repository there. So for those folks that are interested, please go take a look. All right, with that, I'm going to hand it over to Kit and Mina, and they're going to talk about how they've been using X-Ray to delight their customers. Thank you, guys.
Thank you, Abhishek. Hi, my name is Kit Nguyen. I'm the Director of Cloud Services for ConnectWise. I've been at ConnectWise for about 7 years. Started out as a systems engineer. So over the years, I started seeing things moving into the cloud. So about 5 or 6 years ago, I decided to join the dark side, which is DevOps, right? That's where I'm at today. So before we go into X-Ray and talk about our use cases, I'd like to briefly talk about who is ConnectWise and our journey into AWS. So who is ConnectWise? ConnectWise is a software company that connects technology teams with services, solutions, and people so that they can thrive. Here you'll see the 7 core offering that we have. We have remote control and screen sharing and control. We have a professional quote and proposal automation and sell, a remote management and monitoring tool and automate. And to kind of tie it all together, we also offer a business management application in ConnectWise Manage. These 7 core products come together to form our ConnectWise platform offering. As we stand today, ConnectWise have over 24,000 customers. And we have over 100,000 daily active users. And our ConnectWise managed application, as you can see, during a peak time in the day, we have over 2,500 requests per second. This is huge for us. So we needed some insight into what's going on with our environment. So our journey into AWS, like most of you, we were an on-premise data center. We have to buy hardware, provision it. That takes time, high maintenance costs, high operational costs. So we asked ourselves, do we want to continue down that path, or do we want to concentrate on what we do best, which is develop application, provide a good user experience? So in 2012, we went all in AWS. AWS allow us to design a truly distributed architect with high availability, and the best part of it all is we don't have to worry about hardware anymore. So as our ecosystem and ConnectWise grow, we started architecting our application in a more distributed and microservice approach. With that, we started integrating more and more with AWS services. Here is a quick diagram of our ConnectWise Manage with AWS best practices. It's currently in a VPC, multiple availability zones. We integrate with a lot of AWS services such as DynamoDB, simple workflow, simple queuing services. But this presented a challenge for us. We needed insight into our environment. So we started incorporating using CloudWatch, and as you can see, X-Ray. So what was our life like before X-Ray? Well, before X-Ray, like a lot of you, we have multiple system logs, application log, network logs. So if there's an issue, we would go to one or more of these logs to kind of correlate what the issues are and start debugging the process. The problem is it takes a long time to do this. So if we're really good at it, we can find the root cause in an hour, but most likely it takes us 2 to 3 hours to find the root cause. So we started looking for a different way to be able to pinpoint the issue quicker. So we started looking into X-Ray. X-Ray gives us the ability to look into our application, see where our bottlenecks are, where we can see our performance issue is, and it quickly allows us to diagnose what the problem is. We also start integrating it to most of our main architecture component so we can see incoming and outgoing requests. So to kind of tie back and recap why we chose X-Ray. X-Ray gives us different advantages that we like, right? It quickly allows us to see where our bottlenecks are. It allows us to see where we can improve and optimize our application. And we started integrating more with X-Ray. We're using the data that's provided by X-Ray to help with our architecture decisions. So as I mentioned before, ConnectWise Manage is one of our core offerings. This particular application allows technology teams to enter ticket, time detail, invoicing, billing. So it's a very important application to us, and we want to keep it up and running as long as we can, 24/7, with minimal downtime. So we needed more insight into this. So we started incorporating X-Ray with ConnectWise Manage. So here to discuss and kind of talk about how we incorporate X-Ray and the use case with ConnectWise Manage, I'd like to invite Mina Joseph, our Director of Application Services, to talk more about that.
Thank you, Kit. Can you guys hear me? All right. So here comes the best part. Welcome. Hello, everyone. My name is Mina Joseph. I'm a Director of Application Services. I've been a software developer for the last 15 years, and I've been with ConnectWise for 8 years. I'm going to go over some of the use cases with X-Ray, how X-Ray impacted our customers and impacted our business, and provide a few recommendations and lessons learned. So a few years ago, we adopted the microservice architecture. We started breaking our monolithic applications into services that can be shared across all product teams. So AWS services are becoming the main components of our infrastructure. We're using around 60% of AWS services. So having a visibility to that is very critical and very important to us. As you can see in this screenshot, this is just showing a service map, showing how our services are interacting with a simple workflow, and how healthy is that integration. X-ray is giving us valuable information, metrics like latency, error rate, and so on. So having that, it's very good for our daily operation. Since we started using X-ray, we noticed lots of improvements in our debugging process. Before X-ray, whenever an issue happened, we had to go log into the web server, grab memory dumps, and keep going through traces and heaps, and it's not fun. And most of the time, we were not able to capture what was the root cause, so we just wait for the issue to happen again, so we can grab a memory dump and have it wish it's the right time. But now, whenever our customers start reporting issues, the first thing we do is we go to the service map, the X-ray service map. This is our first line of defense. Try to see how, what's the impact, what services are impacted. Try to look for red and yellows, errors and faults. It's becoming our first line of defense. And as you can see, we are integrating X-ray with almost every component of our architecture. For example, with our data access layer. Any DBAs here in the room? No? All right. So we wrap every SQL call with a subsegment. So whenever a request is coming in to our service, we can see all the SQL calls that happen, and we can easily, in less than a minute, identify a bad SQL call that's taking more time. Like this one, you see it's taking more than 12 seconds. Then by including that SQL command itself and some other information in the metadata, in less than a minute, we can pinpoint exactly that bad SQL, and now we can share it with your DBA teams for some advice on optimization. And since we're pushing all SQL and the traces, we leverage X-ray APIs to get all the traces that have SQL call and start logging them, so we can have a daily log of all of our SQL calls. We can now be more proactive on try to fix the expensive SQL calls all over the services. X-ray didn't help us just with debugging. X-ray helped us with making better architecture decisions. It's not just a debugging tool for us, it's more than that. So we have a feature where we push data to the queue. We basically sync the data to the queue. So we have, whenever a record gets created, updated, or deleted, we sync that event to the queue to be processed for different purposes, like indexing for cloud search, workflow setup, or notification, and so on. So we start seeing latency, increased latency. And by going to X-ray, we can easily see what's the problem. We found out that we were pushing data to the queue one message at a time on the same thread. And now the request is blocked. The request is waiting for all messages to go to the queue in order to get the response and to provide it back to the user. So we were able to make a fix based on the valid data and basically start pushing these messages to different worker threads and have worker thread batch them and push them to the queue instead of one at a time. And back to X-ray. X-ray gave us the feedback that now syncing has zero impact on our requests coming in. And as you can see, it's down to 0 milliseconds. Not just X-ray help us improve performance, X-ray help us reduce cost as well. Can anyone guess how did you reduce cost here? So instead of pushing messages one at a time to a queue, we have like around 1 million messages or 1 million events every day. So now when we push them in batches, over time, that's going to reduce costs for us. One of our core values at ConnectWise is customer success. We want to make sure that customers are having the best experience. We want to make sure that they are focused on their business and not distracted by, working around issues in the tool or in the application. Manage is one of the biggest products in ConnectWise. It's data-driven. It's very data-intensive, highly customizable. Every customer has their own implementation. Even users within a single customer might have their different configuration and a different setup. So whenever they report an issue, it's kind of hard to reproduce because it's only happening on their setup. So it's kind of hard to, we have to reproduce that issue so we can debug it. It's not that easy. So X-ray annotation was a big help for us in here. By using annotations everywhere, we were able to filter down transaction by a customer, by a user, or even by records. So whenever you log into the application, sessions get created. We capture some of the session information and start simply adding annotation based on the session information, like customer name. Now you can filter by a customer name and see all the transactions by that customer. Even by username, we can filter down by transaction for a specific user, whoever reported the issue. Even better, by a records. Some users might have an issue with the specific records, but not other records. Might have an issue with uploading a document for some reason, or might have an issue with setting up workflows. So we are able to find the exact cause, the root cause of that issue in a few minutes by just filtering down to that specific record and have X-ray tell us what exactly happened. What about business impact? We were able to save up to 75% for our monitoring costs. Now we have more time. The team has more time to focus more on building new features, focus more on innovation, R&D, instead of spending time scrambling and trying to fix issues and figure out what's the issue. And we were able to capture some analytics. I know X-ray is a monitoring tool. What is analytics is doing here. But as a result of us using lots of annotation, and that was a pleasant surprise for us, is like by looking at the traces, we found we can capture usage metrics. So in this screenshot, we can see popular modules within a specific time period. We can even see popular pages. We can get more metrics, more than usage. We can get latency, error rate, and so on. We've been using X-ray for the last couple of years. We've learned a few things. We've learned a few things the hard way. And we innovated on a few other things as well to try to take advantage of X-ray. So my recommendation for you, in order to take a full advantage of X-ray, is instrument X-ray in every component of your application. Not just setting up downstream, or not just with a SQL call and so on. Just make sure, have X-ray, prepare X-ray to tell you the full story of a transaction. Over time, your architecture is going to evolve. You're going to need a reliable tool to give you a feedback on how your architecture is doing. And for us, X-ray has been a big help. It's like an instant feedback. Whatever we make an architecture change, we can see how it's reacting in production. Also, take advantage of the annotations that you have. And by using the X-ray APIs, you can just, a simple example as running the APIs in Lambda function, push the traces to a Kinesis, and then route them to Redshift, Elasticsearch, anywhere, anywhere you want. You can create your own dashboards. And that's for free. That's even better because you don't have to implement a different solution or a different analytics solution. You can just leverage the existing implementation of your X-ray. Product management is going to love that, I'm sure. So context missing strategy, this is one of the things that we learned the hard way. We had many services all over the place in the cloud. Some of these services are trying to update a segment. That segment doesn't exist. And then we end up with service crashing. So in order to avoid that in the future, we built a small library to wrap the X-ray recorder, basically wrap the X-ray actions, and we call it a safe recording. And what does the safe recording do? Safe recording is just kind of like testing the water. It's trying to do a get entity. So try to see if there is a segment or subsegment exists. If it doesn't exist, it's going to throw an exception. We're going to catch that exception, log it. If the segment exists, we're going to perform the action, whether add annotation, begin subsegment, and move on. Over the year, I consider we built a very powerful logging system. We push, I want to say push like 2 terabytes of data every day, whether CloudWatch or Kinesis streams. And we process these logs and route them different direction based on our business needs, whether it's compliance, auditing, analytics, click tracking, request tracking, performance tracking, and so on. And now we have X-ray. We have a very powerful monitoring system. But now we have these two systems that don't know anything about each other. So imagining having two powerful logging and monitoring, imagine them working together. So how did we do that? We leveraged the trace ID in the header. So X-ray team added a trace ID for every request coming in to the header, whether it's a load balancer or API gateway. We capture that trace ID from the header and pass it along to the logs with every log entry. As well, take that trace ID and create a segment with it instead of creating a new segment. Now, whenever we're looking at the logs and we see log entries like performance metrics that's taking too much time, before, we couldn't know why. We just have to go through the code and scramble and try to guess, is this that line? Is it that method? And we have, it takes us time. But now, it's just a matter of grabbing that trace ID, log into the X-ray console, and plug it in. And X-ray is going to give you the whole story. There is a lot that we want to do, and there is a lot that we can do. But we learned over the years is just to wait. Wait for the next re:Invent because, the team is going to have it, ready for you. And that's it. I'm going to turn it over to Abhishek. He's going to tell us about what's new with X-ray.
Perfect.
Thank you.
Thank you, Mina. All right, so now comes the fun part. This is what I live for every re:Invent, to do a live demo in front of a large audience. So what we're going to do here is we're going to see X-ray in action. I'll quickly walk you guys through the overview of the demo. So we're actually going to walk through the steps of identifying performance bottlenecks, pinpointing specific service issues, looking at errors and faults, performing a root cause analysis, and then identifying customer impact. And then, as I mentioned, we'll also show you guys a little bit of some of the new capabilities that we've built. So give me just a second while I log in here. All right. And let's hit that guy. And all right. So what we have here is a microservices application. It's an e-commerce application that has a bunch of microservices running in various different managed services. I've got database tables. I've got Lambda functions. And then got a few other microservices that I've written myself. And so what we're going to do here is specifically look at, let's say I have a customer complain that the API is slow. And even a very specific complaint, so I'm showing you guys the power of X-ray and the capabilities we have to search on this graph. So let's say that we have the API, and somebody complains and says, I'm making direct calls to the API. I'm not using your front end to make those calls, and I'm seeing some errors and faults. Let's go ahead and diagnose that issue once I have that report. So what we've done here is that we launched this on this past Monday. We built this capability called groups. So what I've built is essentially a group that is, hopefully everybody can read that. If not, I can make that a little bigger. But what I've done is I've created a group called Serverless API. And if you look at the filter expression for this, it's specifically saying that show me everything that originates at an edge that has client on one side and API on the other side. So we're querying for a directional link between client and API. And then we're saying that the service should contain an API gateway. So I've gone in and built a query that says, show me everything that's coming directly to the API from a client, but also make sure that that transaction has an API gateway within it. Having done that, what I get if I click on it, essentially, is that I get a much smaller service graph. So this is not just visual filtering here. What we've done is essentially provided a mechanism to firewall different transactions and provide you various metrics. So if I were to now go look at this particular node, which is my API, the response distribution that you see here is not for all calls to the API. It's for specific calls that go through that specific API gateway and are coming from a client and not from my front end. So again, very powerful capability to really slice and dice your data and create these separate groups where you can go look at the response distribution, the error rate, the fault rate for very specific applications or very specific pieces in your application. Now, having done that, one of the things I see in this case is, as I mentioned, somebody's complaining that I have a lot of faults. I see X-rays telling me that there's 38% of my requests are ending up in faults. So let's actually go click that box, and let's go look at the transactions themselves. Now, what I can do is essentially what I see is that all the transactions that are ending up with a fault essentially are at this product service. I can individually go through each one of these transactions. Actually found 93 of them, scanning across about 7,000 or so. And try to figure out what's the root cause here, right? So I can manually go in and look at each one of those, and it will take me a really long time. So what we're launching essentially tomorrow, this is a preview for you guys. For my X-ray folks here who are interested, this is a special preview. We're building this root cause capability. So you can actually go in here and look at your fault root causes. And what that just did for me is that it analyzed all 90 of those transactions and gave me a group by of all the error or fault root causes. So in this case, what I see is that 58% of these requests that failed because of very particular root cause. And if I hover over this, again, limitation of the screen size here, what I can see is that it was a call from my API to my product service, which then went through the shipping or the API gateway, went through my shipping Lambda function, and then ended up in a Java I/O exception. So it's essentially an exception that I caught. And then furthermore, that Java I/O exception was caused because of a number format exception that I'm not handling. So let's actually go click on that particular exception and go look at a trace and see what that looks like. So here what I've got, again, is you see a bunch of red over here. And this is, again, correlating exceptions across your service boundaries. Right? So we're taking an exception that happens a few steps down here in my shipping service. Or I would say that's the business exception here. But that's the Java I/O exception. Right? So I can go jump in here and see that somebody's not handling a null pointer input. So essentially, I got a nil response. I didn't handle that exception. and that propagated up my stack through a few various microservices, and then ended up causing customer impact. Very quickly with X-Ray, in a few minutes, I would say, I was able to root cause that issue. I was able to literally go find out what's going on and say, hey, developer, can you fix this? Right? So very easy, very data-driven, and that's what Mina was talking about. This was something that they had to do manually. They had to go look through the 90 different traces and figure out what different issues were occurring. And we're solving this problem as of this week by giving you guys root cause analysis or root cause capabilities. Additionally, or in addition to just default root causes, we also have error root causes. So these are essentially the orange colored pieces of your service map. And we also have a response time root cause. So if I want to go dig into, and I'll actually show this in a different view in a second here, but if I wanted to go understand why a set of transactions are slow, you can just load them up here and go to response time root cause, and we will group them together and tell you, hey, this thing is slow because you have a long-running query, as long as that query is instrumented and we have the data, or this is slow because you're waiting for a database, or this is slow because you're making a specific type of call. So that's what this particular, or that's what's available in X-Ray in production today. Now to the really fun part that I'm super excited about, which is the capability that we are looking to announce early Q1. So this is an early preview for all you guys. I hope it's a treat. So let's kind of hop over to what this is going to look like in a few months. So here, I've done the same exact thing. I've loaded up the response time histogram for my service. And this view is essentially what we're calling an analytics view, and it's all about enabling you to answer those 3 questions and really do comparisons on what's going on. So we have a few things here on this view. We have a response time histogram that's telling you the shape of your performance. So what is going on? How slow are my requests? So you see that I have this big peak over here. And let me actually go ahead and select that. So you see that I have this big peak over here, right? So something's going on that's causing a lot of requests to be really slow. And so when I select that, I automatically get a bunch of different pieces of information down here. So what I see is that 70% of requests in that peak are essentially ending up with 500s. So already I know that requests that are slow are ending up in 500s. I also know that the user called Emma is impacted, or 51% of the impact is just for the single user. And then I can go through that list. I also have annotations. So each of these users is making a set of queries, which is a custom annotation I put in there. And what I can see in here is that the distribution's kind of all over the place. Now, the thing that I really want to show you guys that we're super excited about is that you can actually go and then capture or lock that data down. And excuse me, all of a sudden you have this delta column that pops up. And this is, we're going to be doing comparisons in real time. So let's actually go look at what's going on here with slow requests. Excuse me. So what you can see here now is that by selecting these slow requests, X-Ray is telling me that Emma is 18.2 percentage points more likely to be impacted by those slow requests. Similarly, slow requests are 43.17 percentage points more likely to end up in 500s. The other interesting thing is that I can simply go down and look at the root causes. And in this case, because I'm looking at response time, I have this top root cause that's telling me that these requests are slow 24.17 percentage points because of a weight that I have in DynamoDB. So let's actually go click that. And once I click that, the rest of the requests are filtered. I have a whole bunch of requests here that are essentially sample transactions where that root cause is true. So let's actually go look at one of those. And once I pull one of those up, I can actually go start looking at this, and that's what you get. So what I have here, for those of you who've used AWS SDKs, they have inbuilt retries, and the retries are exponential. So what X-ray is doing is essentially it's going through this graph or timeline for you, and it's going and collating. It knows that the weights are essentially part of the same RPC or the same transaction, and it adds all of that up and says a large chunk of your request time is being spent waiting. And so as you can see, this is visually very clear. I have a request, then I end up in wait, wait, and that time keeps getting longer because it's exponential wait. And eventually, I get through and it finishes. So again, super powerful capability to really understand the differences between A and B. Why is a customer behaving differently than another customer? We can tell you that using mathematics here. So very excited to have this out early next year. For those of you who are already using X-ray, if you want to be whitelisted for this, we'll probably start a beta, I would say mid to late December. So please reach out to your account manager, or you can tweet at me. My Twitter handle will be at the end, and we'll kind of take you from there. So with that, excuse me, I'm going to switch back to my slide deck and quickly run through a few pieces of additional information. So in terms of what's new with X-ray, these are some things that we've launched in the past year. We've made sampling easier with dynamic sampling. We've added support for API Gateway, and we're building root cause analysis features so you can actually go look into why your traces or why your requests are slow pretty quickly. X-ray pricing, this is super important. We're usage-based or pay-per-use. The first 100,000 traces are for free. So essentially, if you have an app that does less than 1 request a second, you can trace it for free. The first 100, or I would say million transactions that you retrieve from the system are free. And then beyond that, it's a $5 per million traces ingest fee and a 50 cents per million traces extract fee. Some of the key takeaways that I quickly want to recap. So X-ray helps you understand issues in your applications and get to the why and the who. You should absolutely be using annotations to add business data to traces. It makes the system way more useful. Use metadata to capture details such as inputs and remote call responses. Makes it much easier to debug, as Mina had shown you. He's capturing SQL queries, but you can capture responses. Use groups to break up large service maps, get metrics for those service maps, and then use them for notifications. So essentially, a group emits a metric that says the number of traces that match it. And then you can do things like, for customer A, I have an SLA of 500 milliseconds. If that is breached, emit a metric, and then you can use that metric to alarm on that case. And then X-ray now provides automated trace analysis for latencies, errors, and faults. I'll let you guys take screenshots of this if you want, or screen grabs. All our SDKs and daemon is open sourced, so these are the link to the repositories. We also have a bunch of sample applications that we have up there, so please feel free to go look at those. And then finally, thank you guys very much. I appreciate you guys sticking around, and we'll switch to Q&A. Before that, please do complete the survey. It's a way for us to get feedback in what we can do better next year or the next time we go around. So appreciate having you guys here. This was a great audience. Thank you very much.